So this is Edx Further Maths Core Pure. It's the second matrices section, and we're on the fourth video on successive transformations in 2 dimensions. So here's a series of standard 2D transformation matrices that we've come across in previous videos. So we've got reflections, rotations, remembering that anticlockwise is positive, and we've got stretches and enlargements with scale factor k. What we're looking at here is successive transformations, so one transformation followed by another transformation. So we've got a transformation A with an associated matrix A, and that's followed straight away by a second transformation B with an associated matrix B. So let's have a look what happens when these two transformations are combined. So I'm going to apply matrix A first, which is 1, 0, 0, minus 1, to some general point xy, multiply these matrices, and I get x minus y. This tells me that for any point, the x coordinate will remain the same and the y coordinate will change sign. So you could see that this means that my triangle will be reflected in the x-axis. So that's the first stage of the transformation. I'm going to follow this then by transformation B. And again, looking at a general point, this will become minus y x. So the point here, so 1, 2 goes to minus 2, 1. And we can follow that through, and we find that the triangle has been rotated 90 degrees anticlockwise about the origin. So there's the result of carrying out A followed by B. And if we take a look at the products of the matrices, so if we look at AB, we multiply these two matrices together, we get 0, minus 1, minus 1, 0. So that's AB. If we multiply them in the other order, remembering that matrix multiplication isn't commutative, so in general we won't get the same result. We get 0, 1, 1, 0. So which one of these could represent the transformation from this directly to this? You should be able to see that the first case doesn't work. This would be a reflection in the line y equals minus x, but we've got a reflection in the line y equals x. And you can see from the two shapes that that is indeed what we've got. So BA would represent the single transformation of A followed by B. So to summarise this, in a general case, if we've got two transformations represented by matrices M and N, the matrix NM will give the single transformation that represents M followed by N. So M first and N second. Very much the same as composition of functions. If we multiply the other way around, Mn, what would that give us? That would give us N first with M second. So here's an example. We want to find the matrix S that represents a stretch of scale factor 3 in the y direction parallel to the y-axis, followed by an anticlockwise rotation about the origin of 90. So our first transformation, the stretch with scale factor 3, would be represented by 1, 0, 0, 3. So that's our first. And then second, we have our rotation, 0, minus 1, 1, 0. And if we multiply these two matrices, we get 0, minus 3, 1, 0, and this is S. So stretch followed by rotation. And we can see here the transformation S, 0, 1, minus 3, 0, transforms ABC to A dashed, B dashed, C dashed, and you should be able to tell that we've undertaken a stretch parallel to the y-axis of scale factor 3, followed by a rotation about the origin of 90 degrees anti-clockwise. So that's the end of this short video. The next video in the section will be on transformations in 3D.